Welcome back. In this recording, we're going to take a quick look at macromolecules once again and just focus on the stepwise synthesis from monomers. So hopefully you can recall the major macromolecules of the cell. So these macromolecules that are responsible for most of the form, order, and therefore function of biological systems are generated by the polymerization of smaller organic molecules. And those smaller organic molecules, those repeating units, are called monomers. So for example, if you think about starch or cellulose or glycogen, the repeating monomer there will be glucose. And then if you think about nucleotides, they're going to polymerize to form nucleic acids, amino acids into polypeptides. So the major macromolecules we call are proteins, carbohydrates, nucleic acids, and lipids. Now all except lipids are produced by polymerization of organic polymers, and lipids, although a macromolecule, aren't produced by polymerization, so we're not going to talk about them too much here. When we think about things like proteins and nucleic acid, there's a variety of monomers. Obviously there are 20 amino acids and 4 nucleotides, so that creates a huge variety of molecules that can be produced, and obviously that gives us a huge variety of structures and therefore some diversity in function. So if we're thinking about diversity of function, is what I mean there. If you're thinking about nucleic acids, there are many functions, as many functions of nucleic acids really as there are genes, if we think about it in that way. And the same thing goes for proteins. There are many functions because there are many different proteins due to the many different ways you can arrange the 20 amino acids. Polysaccharides, on the other hand, excuse me, I've got some allergies, sorry. Polysaccharides, on the other hand, are composed only of a few types of monomer, and so we see relatively few types of polysaccharides. So that's just a real quick overview. Let's just step through very quickly the basics of polymerization. So remember, macromolecules are always synthesized by the stepwise polymerization of monomers, except for lipids. So we're just focusing on the polymeric macromolecules right now. When you join the monomers together, so when you add monomers and you link them together, that involves the production of one molecule using some chemistry called condensation. Now, something new that I'll introduce here is the idea that monomers to be linked together must be added to a carrier molecule, and so they're said to be activated. And so before you can do the condensation reaction, you have to do this activation step up here, and that involves a high energy molecule, often something like ATP. And so there's the activation of the monomer and its addition to a carrier molecule. So if you think about something like an amino acid, that's activated by the addition of the amino acid to a tRNA, and so the carrier there is the tRNA, and nucleotides are going to be different. Polysaccharides or glucose are going to be things like UDP or other kinds of nucleotides that can be used as carriers for polysaccharide monomers. And when you link these monomers together, you often see a directionality, and I've often talked about this before as a polarity, in that the two ends are chemically distinct. And so some people find that confusing because we talk about polarity in terms of charges, and we talk about it in terms of things like covalent bond polarity. So you can use the word directionality if that helps a little bit. So if you think about a polypeptide, as that gets synthesized, you have an N terminus and a C terminus. So there's directionality in that. If you think about nucleic acids, there's a 5' and there's a 3'. And even when you polymerize sugars together, you have chemically distinct ends. And so the nature of the polymerization gives you directionality in the macromolecules. And again, we're not worrying about the lipids here. Now, if we're going to reverse that process and we're going to break down the macromolecules, then we do hydrolysis, and that's going to use a water molecule. Hydrolysis literally meaning the splitting of water, and is what we're doing is we're using the splitting of that water to break the covalent bond that links the two monomers together. So for example, a peptide bond or a phosphodiester bond or a glycosidic bond in a polysaccharide. So that is just some very quick review about macromolecules. Again, really fundamental stuff that I don't want to slip through the net. And when we come back, we'll talk about something new. We'll talk about self-assembly in cell biology. I'll see you next time.